Welcome to Natural Habitat Adventures Daily Dose of Nature. White whales beguiling belugas of the Arctic, presented by NatHab Expedition Leader, Eleanor Edye. Thank you so much for being here today, Eleanor. I'm going to hand it off to you.
Thanks, Kendall, and welcome everybody. I was tempted to ask you to say that title 5 times fast because I only realized how much of a tongue twister it was after the fact. So, like Kendall mentioned, my name is Eleanor Edye, and I'm an expedition leader here with Natural Habitat Adventures. And today we are here to speak about probably my very, very favorite mammal, the beluga whale. And throughout this presentation, just to kind of let you know, there are some images of beluga whales kind of in captivity where I need to point out some very specific features. So I tried to focus on natural environment photos for obvious reasons, but if you see an animal in captivity, it's not ours, and it's just to demonstrate some very specific morphology of the animal. What I want to focus in on are experiences and stories about what you can see on the left-hand side there. So I'm an expedition leader based in Canada, and I live in the southwest corner of the province of Manitoba, so directly above North Dakota. And I do a lot of our Churchill expeditions, including the beluga whale trips in the summer. And you can see an image from a couple of years ago here. I had a wonderful time, as we do every time when we're out with the beluga whales. And I had 2 whales who just followed behind my kayak for the better part of an hour, bumping me around. They are just such fascinating organisms and beings. And I'm so glad that you chose to join us here today, and I hope that all of you get a chance to, at some point, see one in person if you haven't already. So let's get into the biology of beluga whales. So we have here a poster of all the currently living whale species of the world. Depends who you ask and who's counting, but there are 89 or 90 species of whales that are extant, meaning currently living globally. And since you're here, I'm going to assume that you care about whales, or you know a little about whales in general, and maybe belugas specifically. But I know for me, and I'm not a cetologist by any means, I'm trained as a botanist, but I do love whales. If you asked me to, if you crossed off all the names on this chart and asked me to name them all, I couldn't. I'll be quite honest with you here. I could name the big ones, I could name the common ones, but there are a lot of whales that we don't think about or hear about very often. And beluga whales, despite the fact that they live quite polar, quite far north, are whales that actually most people are familiar with or interested in. And I think that's really fascinating as to why this really remote small whale draws so much attention. So I've got an arrow here pointing at our beluga whale, and there we go, gonna have a red circle popping up right away, and that is circling the family that the beluga whales belong to. So the beluga whales, the scientific name is Delphinapterus lucus, meaning white whale without a fin, and they belong to the family Monodontatae, which means single-toothed whale. There are only 2 species in that family, the beluga whale and the narwhal. So they are fairly closely related. I think, honestly, a lot of the reasons why some of us start being drawn to beluga whales, and something that I know is true for me and it might be true for you, is that beluga whales are actually quite represented in aquaria around the world. They are easily trainable. You can easily put them into captivity. They're long-lived, they transport well, they're charming as anything. So the first time I saw a beluga whale was at the Vancouver Aquarium. And we have beluga whales in captivity around the world. Canada no longer permits new whales to be brought into captivity, but you can see them in other places too. And it always is what it is, but I think it has been a gateway for a lot of people to develop a lot of better understanding and especially appreciation for these really remote organisms. Now, what I'd like to talk about throughout today is what makes this beluga whale so special, and how does it survive where it does? Not just survive, but thrive in those cold, barren Arctic waters. And I want to start this at the beginning to take a look at some of the ancestors of this species and a short trip through its evolutionary history. So to start talking about whale history, we're going to take a fairly big step back in time, but we're not going to stay here too long. And I'm going to take you back to the Eocene. So this is the time around 55 million years ago, because prior to this point, before the 55 million year ago mark, there were no whales. There's no whales anywhere. The Eocene was a fairly warm time. The estimates are that globally, the temperatures were between 9 and 14 degrees centigrade warmer than today. So that would be about 20 to 30 degrees Fahrenheit warmer than today. And what this meant in terms of habitat is that the continents were pretty close to where they are right now, but sea levels were higher and there were lots of very warm and shallow seas. So lots of aquatic habitat that doesn't necessarily exist today. Now, 55 million years ago, you're thinking warm, tropical, what's not to love? But think about what happened just a little bit before that. If we go back to 65 million years ago. 65 million years ago, of course, there were no whales then either, because I said there weren't any. But also, those seas were full. They were full of aquatic predators like the mosasaur that were all present before the extinction of the dinosaurs. And when that meteor came 65 million years ago and eradicated the dinosaurs, it also eradicated all of those predatory aquatic animals that were affiliated with the dinosaurs too. So it left these great big ecological holes to be filled. Now, at this point, we know that there were no mammals above the size of around 50 pounds or so that survived that mass impact. And it took some time for biodiversity to re-evolve back to the point where you could actually support a large aquatic predator. But it did happen, and around the 55 million year ago mark is where we start to see evidence of the very first whales. And this animal here that you can see on your screen doesn't look much like a whale. It doesn't look much like a whale as we know it. So this animal is named Pachycetus. It was the first whale, and it was a land animal. They were endemic to Pakistan during the Eocene. So I'll just flip back for a second there. If you look at on this map where the yellow star is, this is where whales first started in this form of this Pachycetus. We don't know how many they were. We don't know exactly how hairy they were or anything like that. But we do know that they were the precursor of all whales that currently exist. And we know this specifically because of a very specialized structure inside the ear of these animals that is only found in the cetacean line. So it's only found in whales. And it actually is a structure that fossilizes. So anytime that a potential whale fossil, as long as it includes the skull, is found, we can say for sure whether or not it belonged to that line, at least as far as our current understanding goes. Now, like I said, this was a land mammal, probably, but it was probably partially aquatic as well, based on how it was built. So it had very heavy bones that were likely used for ballast. Its eyes were near the top of its head. So if you look at that reconstruction or at the skull itself, it would be similar to something like a crocodile, right? Where they could float in the water and their eyes just hung on top and they could see their prey coming and then ambush them while being hidden underwater. Whether or not it could fully support its weight on land, we're not sure, but it definitely had feet, right? It definitely was almost definitely semi-aquatic. Now, like I said, the first whale 55 million years ago, and keep in mind that our oceans at this point were empty of large predators. And nature does not like leaving holes unfilled, doesn't like vacuums. So if there is space for many kinds of predator or many kinds of animal, those animals are going to radiate out and develop new forms and new species to fill those spaces. So speciation amongst the whales happened fairly quickly. This is one that came in just a few million years later. This guy's name is Ambulocetus. And again, this is an artistic reconstruction. Ambulocetus means walking whale, right? They're about 3 meters long, so about 9 to 10 feet. Obviously extremely different from what we think of as today's whales. Had the same type of structure as Pachycetus, so dense limb bones, eyes on top of its head, huge jaws and teeth, right? It almost looked like a mammalian crocodile. And these guys stuck around for a few million years, seems to have been restricted to fresh water. And once they hit that marine, that saltwater environment, we got a lot of species that came in, like I said, very, very quickly. So species like Basilosaurus, like Dorydon. In fact, if we think about Basilosaurus, if you hear it, you think must be a dinosaur, right? Basilosaurus. And that was the original thought when this when the fossils were first found from this genus. So it was named as if it was a dinosaur, and then they realized later on it was actually a basal whale. And it probably fed on Dorydon, which was about the size of a dolphin. So these were found in many areas around the world, widely distributed. And so by that 40 million year ago point, we went from having no whales 55 million years ago to 40 million years ago. They were completely aquatic and they were spread around the globe. And by 35 million years ago, we had our last major split in our what led us to our modern whales. So the last common ancestor of all the whales that are currently living was 34 million years ago. And that was the big split between what we now know as the toothed whales, like dolphins, like belugas, like the narwhal, and the baleen whales, like the blue whale or the fin whale or the humpback whale. So it's always just so fascinating to me how quickly these things can happen when there is space and opportunity for animals to take advantage of this. So just be aware that, like I said, today we have around 89 species of currently living whale, and we have had far, far more than that in the past. So there have already been more whales that have evolved and gone extinct than we have on Earth today, even though it's a relatively new group. Now, to zero in on the belugas, because I think this is, obviously we're here to talk about belugas, but it's quite fascinating to see where that family, that Monodontidae, came from. Remember I said that the Monodontidae included just the beluga whale and the narwhal. Now, those are both very northern species. But if you were to look at this bottom map here, those green dots represent fossil remains of other animals from the Monodontidae. They're all fairly far south. So it looks, the current scientific consensus is that it looks like this family evolved in the southern temperate regions and then moved up north as conditions changed. From about 2.5 million years ago or so, if we look back in time, it was a colder time than it is right now. So we were certainly during a glacial time. So the thinking is that even though we saw those fossils popping up in what would today be warmer regions, those would actually still be cold times that 2 to 3 million years ago. So this organism that you can see here, this is Cassacea, and this is the most recent find of the fossil monodontids. And this one was found just in northern Italy. So here is the current range of the belugas in the northern hemisphere, because they are a northern hemisphere organism. If you look at the yellow and the yellow hatched lines all together, that is their that is the habitat that they use throughout the year. The annual range is the one that's in just flat yellow, and then the hatched regions are just their summering regions. But you can see that it's fairly far north, right? It's mostly within the Arctic Circle. And if I were to show you a map of the sea ice, which I'm about to do, you would see that, in fact, it overlaps nearly exactly with the habitat of the beluga whale. So the beluga whales are really, really species of the ice. And this is kind of, it's mind-blowing for a lot of people, because you think, they're whales, right? The other whales that we think of, they're always in areas with open sea. they're mammals. They have to breathe air. So what the heck are they doing in areas where, if you look at the extent of the sea ice, it's pretty well covered anywhere that they live. So how are they so adapted to this region? They have a number of specific adaptations that let them take full advantage of this region. So the beluga whale, look at them here in the ice. So they are a species of the ice. They are comfortable when there is ice around them, you know, to a point. Just a few things to start off with as we get into these specific adaptations for living in the Arctic. If you've never seen one before, I just wanted to talk about how big they are so you can scale these images in your head. So an adult male will be up to about 3,500 pounds and about 18 feet long. And females will top out around 80% of the size of a male. So a little bit lighter, a little bit shorter. And you can sex them to look at them if you look really hard and if you get a look at the proper parts. I can't tell you from this photo here whether we have males or females. So the name Delphinapterus lucus, remember I said it means dolphin without a fin, and lucus means white. So it's the white whale without a fin. And like the narwhal and like the bowhead, the other whales of the Arctic regions, they do not have a dorsal fin. So they're showing you here their backs, and think about other whales or dolphins that you've seen. They all have that dorsal fin, right, to aid in steering. These guys don't have that. And let's think about why that might be for Arctic whales, an advantage to not have a dorsal fin. It's primarily due, we think, to greater maneuverability under the ice. So if you have a great big sail, that's basically a sail sticking up off your back, you have less room than you can move in when there is shifting ice all around you. We also know that the dorsal ridge, because they do have a very hard ridge along their back, if they push up on ice, they are able to break through ice that's up to about 8 inches thick using that ridge. And so even if there's been, like, for example, a quick cold snap and they've had a big freeze up in the area that they're in, as long as that ice isn't really, really thick, they can fairly easily break through that to be able to still take breaths in the air. Now, they're not fast whales. They're not like spinner dolphins or anything like that. Their fastest recorded speed is around 27 kilometers per hour, so about 15 miles per hour. But they usually tootle along like between 1 and 10 kilometers per hour, so it's at around half to 6 miles per hour. They're more built for steadiness as opposed to speed. Now, another adaptation that they have for living underneath the ice is what is called unfused neck vertebrae. And if you've never thought about the neck vertebrae on whales, that's okay. It's like you and me. So you and I, we can turn our heads, we can look left to right, we can look up and down, and that lets us both visualize the area around us, but also if you were swimming, that could help you move around tight areas. And that's exactly what beluga whales use it for as well. Again, in an area where tides move, ice flows around, waves and winds push the ice around, they may find themselves in a very small area where they need to turn around without running into ice. So having those neck vertebrae unfused allows them to turn their head, to look, to do flips. They can actually tuck their chin in and do a flip very quickly. And if you were to put them beside, for example, another dolphin or an orca, they are so much more maneuverable than those other whales are. They can also just turn their heads and look at you when you're in a boat and they're in the water, and they often do that too, just to check you out. Now, this next photo is not one of mine. You may have seen it on the internet, but it's one of my favorite photos of beluga whales. It makes me feel just so good. So they are very fat organisms. By weight, they are 40 to 50% body fats, and that is laid down as blubber. Blubber is different from the kind of adipose tissue that humans have. Blubber is highly vascularized, so it gets a lot of blood supply. It's actually integrated into the musculoskeletal system. So it's both an insulator and a source of food, but it's also part of how they move their muscles and move their skin and move their body. So this guy, he's not showing us his six-pack. He's showing us his happy little rolls. And this is a whale in good condition, right? We want to see whales that have that amount of body fat because they are swimming in waters that are often actually below the freezing point of fresh water because they're in salt water. So they may be swimming in water that is in Fahrenheit, 29 or 30 degrees Fahrenheit, or -1 or -2 in terms of your Celsius. Now, that blubber also helps with buoyancy. It streamlines them so they're just able to move so easily and comfortably through the water with that amount of body fat. And can never talk about whales without talking about what makes the whales here, because I think even though I've said how well adapted they are for the cold, and the fact that they are organisms of the cold, it's hard for us as humans to say, well, why would they want to be there in the first place? Like why would you want to put out all of that energy, all of those adaptations to live in a cold, harsh, northern, icy environment? And while they are one of 3 species of whales that stays there year round, the northern and southern latitudes, so the polar regions, are actually really, really popular areas for whales to go to, at least in the summer. Though, like I say, the belugas stay there year round. And what makes this such an extremely productive area is that it's actually like a little ice garden, even underneath the sea ice. So we have if you've seen some of my webinars before, I've shown you this picture before. This is a sea ice core. And that brown layer on the bottom is actually where algae is growing within the sea ice. So that is called algae or phytoplankton. It colonizes right into that sea ice. And you can think of the sea ice like an upside down garden that is growing year round. And if you were to swim underneath that sea ice like a beluga would be, you can see that algae growing there. And to you and me, it doesn't look like much. To organisms that feed on the algae, it looks like a feast. So these primary producers, though they may not be as in your face as the Amazon rainforest, still support an incredible array of large mammals like the beluga. In fact, if we were to look at which areas of the world are most productive in the ocean, the northern and southern high latitudes are actually the most productive regions in the world. And if those little red blips are actually like those coastal regions along Hudson Bay, along the northern coast of Russia, incredibly, incredibly high productivity areas. So they go on to grow lots of little plants, which go on to feed lots of little organisms like copepods. You can see these algal blooms from space. So this is a summertime bloom north of Norway. And all of this goes on to feed organisms like the copepods. So copepods are a small krill-like organism that feed on this algae. And again, while they might not look like much to you or me, they are very, very efficient at eating that algae and concentrating that energy. And that little bubble that you can see midline in those various copepods is actually a fat sac. And if you've ever listened to any of our polar bear presentations, you know that fat is how energy likes to transfer in the Arctic, because you can pack so much of a punch in such a small package. So fish that feed on the copepods also really benefit from those fat accumulations. And the main prey source of the beluga whales feeds directly on those copepods. So these are capelin, which belong to the smelt family. Now, the range of the capelin is nearly identical to the range of the belugas, and they are an incredible food source for these whales. If you come up in the summer and you see the beluga whales feeding, you can see the shimmering of a school of capelin, and then you just see the whales just going right after them, because that is their main food source, especially in the Churchill region. Now, they aren't the only ones who eat capelin. Other whales, seals, cod, mackerel. Seabirds will also eat these. They are a spawning fish, so they will leave their wintering grounds and swim upstream into a large number of Arctic streams. Lay their eggs, the males tend to die, and then the females swim back out. And the young do as well later on. So they're not a big fish. They reach about 8 inches long, give or take, a little bit bigger for the females. And they just spawn in, like you can see here, these incredible numbers. So even though a beluga whale, like we said, 3,500 pounds at maturity, the biomass of the capelin is so incredibly high in the north that it's enough food for the belugas, even for as many belugas as we have worldwide. And this whale coming up is going to demonstrate how they go about eating those capelin. So they are toothed whales. And if you have a look at those teeth, right, they look kind of pokey and sharp, but they're really not. They're pretty rounded, and they don't use them for biting prey. I think about the size of those capelin, like I said, 8 to 10 inches long. What they're more using their teeth for is actually as they close their jaws around a school of capelin, they can then push out any water outside their teeth and then just swallow a mouthful of capelin whole. So they're not chewing anything, they're just using it to capture prey, just like a claw in a claw machine, something like that. Now, capelin are mostly a higher, they're a fish of the upper ocean. So beluga whales don't need to dive super low to catch them. As such, beluga whales are not known to be deep diving organisms. The longest reported dive is only 23 minutes. And you can contrast that to some other whales that have dives upwards of 3 hours, that's a whole different mind-blowing story. These guys, like I said, they're not very fast. They don't dive very deep. They don't dive very long. They just do what they need to get the job done. So, like I said, that capelin, it's their main food source. It can be upwards of 95% of their food, depending which population we're looking at. But they can eat other things as well. So around the world, beluga whales may feed on Arctic cod. They may feed on herring, Arctic char, various mollusks and squids and crustaceans. So what they eat depend mainly on where they live and what's available. So they might always prefer the capelin, but ultimately, if they're going to come across a group of squid, they're probably going to feed on the squid as well. And same thing with jellyfish. We see a lot of them eating jellyfish in the Churchill region too. I love this photo too. I'm very entertained by beluga whales most of the time. So they don't just have heads that can turn around, they also have lips that can move in some ways fairly similar to our lips. So they can purse their lips, and what this lets them do is things like bubble blowing. That's mostly for fun, as far as we know, or for sending messages, but being able to purse your lips also means that they can suck water and prey in through a high pressure jet. So they do use this feeding strategy as well, especially when they're feeding on shallow river bottoms. For example, if they're tootling along the bottom, feeding on mollusks, they can just purse their lips, suck in a whole bunch of food all at once. Now, just before we move on, I think bubble blowing is really cool. Little aside about this. This has mostly been observed in captive beluga whales because you would have a really hard time seeing it in native populations. But this activity has been studied in aquaria over the course of many years by various research teams. And it's actually been found that these whales at different aquaria, so it's not a communication thing that's happened within a single location, they blow bubbles for different reasons. And each type of bubble that they make corresponds to a different reason. So they might blow like a bubble ring as a playful thing. So they've actually been seen to blow a ring of bubbles, and then another beluga will come and pop. So it's like they're playing with each other. I blow bubbles, you pop them back and forth. But they also do things like use bubbles as a defensive reaction. So mother belugas have been seen to push a high velocity bubble stream at, for example, males that are coming too close to newborn calves or other whales. So something really cool. I think it's as hard as it can be sometimes to see whales in aquaria. It is cool to know that there's still a lot of scientific advances coming from the whales that we can see in captivity. So cool behavior that likely happens in nature as well, that just hasn't ever been seen, but has been seen in multiple aquaria. Now, as toothed whales, they do also have echolocation. So echolocation is present mostly only in toothed whales. So remember, about 34 million years ago, we had that big split between the baleen whales and the toothed whales. Echolocation seems to have developed right around that time and possibly after that split. And we think that all toothed whales have some amount of echolocation that they can use. So in a beluga whale, they produce sound waves up in their nasal sacs, and they use the melon at the front of their head. It's not like the big bulbous thing that you can see in beluga whales on their skull. They kind of look melon-headed, right? It's not part of their skull. It's actually a fluid-filled sac called the melon, and they use the melon like an acoustic lens to focus the sound waves going out from their body. And then as the sound waves hit something like the bottom of the river or a school of fish, they bounce back towards the whale, and they get accepted not through the ears, because they don't have external ears like you or I do. They actually get accepted in the jaw of the beluga whale, which is filled with fat-filled cavities. As those sound waves hit those fat cavities, the sound gets transferred up to the inner ear, which then gets relayed to the brain like something like an image, that there are fish over there, or there is a rock over here. It's really, really cool, and you can see videos on YouTube or elsewhere of what it looks like as a beluga moves its melon. It's quite, it can move it a lot, and it can even be moved on like purposefully, like they can be trained to move a melon. Now, in terms of their life cycle, newborns are fairly large when they are born. They give birth to a single calf at a time. Those newborns are between 30 to 50% of their mother's body length. So they are quite large in relation to the size of the mom. And females start to breed somewhere between 4 to 7 years old, males between the age of 6 to 7 or thereabouts. So you can see here in the image that a mature beluga whale is quite white in color, whereas the newborns and the youngsters start off they actually start off more like a terracotta color that very quickly darkens to gray, and that as they age, they will get lighter and lighter. And by the time they reach sexual maturity, they will likely be either that pure white we come to know of as quite characteristic of the beluga, or at least light gray. If you see a light gray whale, you can know it's basically like a whale teenager. We don't know a lot about the mating habits of the beluga whale because they happen in very, very remote areas. We think that it happens in late winter, and we think that gestation is around 14 months or thereabouts. We do have a lot more witnessed calving because calving happens in late spring or early summer. And this tends to happen in the southern summer areas of their habitat range. So these have been witnessed by people to see the births happen. The combination of pregnancy plus the period of lactation will last around 3 years. And there have been cases where females have suckled their previous offspring as well as their current newborn as well. So you can see here from this newborn how much smaller it is, even though it's fairly large in relation to the mother, but it's also not very fat, right? So one of the reasons we think that they always give birth in their summering areas, which I'll talk about in a second as to what they're like, is that the water is warmer. So you can have a skinny baby whale that's not going to freeze. It's not going to have any major implications for cold water without any issues there. And just one more picture of a baby whale here because they are so incredibly adorable. So this is a newborn whale. And I know it's newborn because when I was there, and there were newborn whales all over the place, you can see that it's not dark gray in color yet. It's still that kind of mottled terracotta color. And also with newborn whales, they tend to actually almost ride on the side flippers of their mum. So every time mum comes up to take a breath, the newborn will actually pop their head all the way out as they breathe. And they don't do that for too long. You know, if you see that kind of behavior, that you have a very, very young whale on your hands. Just as another example, another shot here of what they can look like when they're young. So this is a whale that's darkened up some. It's still mottled. It's still a very young whale. And you can see how different that color is for a young whale in relation to a mature whale. So those white whales being, of course, the mature ones. Now, in terms of where they're coming from and what they're doing, so I'll talk specifically about the Canadian populations mainly, but just do know that worldwide, there's an estimate of around 150,000 beluga whales, of which 2/3 are found within Canadian territorial waters. We recognize 29 global populations, of which 7 are recognized in Canada. And those 7 populations are defined mainly by their summer habitat. A lot of them will actually share winter habitats, but they seem to be quite philopatric, meaning that they tend to return to the same place year after year. And they don't necessarily seem to interbreed all that much with other populations. So looking at the map of Canada here, I did put a star on Churchill, and you can see that altogether the black and gray are the summer and winter habitats put together, and the black regions are the summer habitats. So you can see here that for the most part, the summer habitats are further south than some of the winter habitats. And this is because they are moving into either an estuary or all the way into a river area for that birthing process. Remember, they are looking for warmer water. They're also following those spawning capelin as well. Keeping in those shallower estuary waters helps them avoid predators. And beluga whales are actually unique as well in that they don't shed skin cells continuously like you or I would, or like other whales do. They actually shed their skin kind of all at once or over at least a couple of week period. So that as they move into those estuary areas that are predominantly gravel bottomed, they actually will scrape off last year's skin and have this year's skin come out. So if you ever see them in the early spring, they can be quite yellow looking and mottled, and that yellow skin is the old skin that's going to be scraped off as soon as they get the chance. So I'm going to talk mostly about that Churchill population. So the Churchill population, again, Churchill's marked there with the star. Churchill belongs to the Western Hudson Bay population of belugas, and worldwide it is the largest population of beluga whales. So the Western Hudson Bay population overall has about 60,000 beluga whales, and they will use a variety of estuaries in that region to come in, give birth, feed, chase the capelin, do all that fun stuff. So this is the migration routes, and it's going to hopefully answer a question that you might have in your head is, firstly, well, you're telling me where they go in the summer, but where the heck do they go in the winter? Okay, so all of those black areas are the summering areas. So southern areas into the estuaries following the capelin. And if you track those arrows around, you can see that they kind of come down along the east side of Hudson Bay, following where the ice opens leads to get into their Western Hudson Bay region. And then as fall progresses and as things start to freeze up, they will actually move further north into that area there between the northern tip of Quebec and the southern tip of Ellesmere Island, or sorry, Baffin Island, and that is the Hudson Strait. So Hudson Bay is our big body of water there, and Hudson Bay gets, it is salt water, and it has most of its water coming through the Hudson Strait. Hudson Strait is a fairly small area to push that much water through, and it actually has, in that strait area, it has a tidal range of over 40 feet because of all the water that is moving in and out of Hudson Bay on a daily basis. And what it means as that incredible tidal range and as all those currents are moving through that area is it means that there is an area that is consistently ice-free throughout the winter. So that Hudson Strait, also known as the Hudson Strait Polynya, the area of continuously open water, is their preferred wintering area because that way they're not in danger of entrapment by ice or any other problems in that way. But the Churchill region whales, like I say, the Western Hudson Bay gets around 60,000 whales. The Churchill River estuary gets around 3,500 of those whales that come into the Churchill River. And they're just so fantastic, you guys. I think they're just the best. They come in pods, so the males will travel together, and then the females with the young will travel together. They don't tend to overlap too much between the different pods, and those pods might contain anywhere up to about 10 individuals. And they come in as soon as it is light enough to trigger their brains that it's time to migrate. It's a pretty special place to come and view the whales because the water can be incredibly clear. And these are very, very gregarious whales who, you know, they're going to do their whale things. They feed, they sleep, they mate, they give birth, they lactate. So they're doing all those things, but they are also often quite interested in what the humans are doing. And it often feels just as much like they're here for the human show, just as much as you are there for the whale show. So just to show you what whale watching activities look like in the Churchill area, it's mostly done on smaller boats, and you're quite close to the whales for the most part because they, even though we are not allowed to approach whales beyond a certain distance, the whales can choose to approach us, and they almost always do so. And it's hard, I think, for those of us who don't spend that much time in areas like this to really grasp what that can look like on the ground to have 3,500 whales within an estuary. Even though they're in pods of around 6 to 10 individuals, simply the fact that we have 3,500 whales that go into an estuary that's maybe only 1.5 miles wide by a few miles long, it is incredibly densely packed with these mammals who are then feeding on those fish and those jellyfish and all the crustaceans and other things that we were talking about there. So they're there for the feeding. They are there for giving birth. They will nurse their babies for a month or two before they start heading back up north to the Hudson Strait area. And in terms of when calving happens, it's usually in late June in this region. So we see those newborns through July for the most part. Now, there are some conservation concerns as regards beluga whales. And we get asked a lot, like, are there natural predators? Like, what comes for beluga whales? So very, very rarely in the summer do we see this, but it is a natural predator on beluga whales are polar bears. So this, on the left-hand side, these were images taken from a Nunatsiaq News, which is a community newspaper in Nunavut. And they had a group of whales that had become entrapped by ice and had a very small breathing hole that all these whales were taking turns taking breaths at. And a polar bear found it. And sadly, everything needs to eat. And this polar bear just wore down these whales until he was able to capture one and drag it out. And even though a polar bear might be 1,500 pounds and a beluga whale is 3,500 pounds, a determined polar bear can take a beluga whale out of the water given the chance. And in fact, even in the summer, I haven't seen this personally, but we've had reports of this. There are some areas of Hudson Bay where there are overhanging cliffs, and polar bears have actually learned to stand on top of the cliffs and jump onto whales down below in the water so that they can hunt them even in the summer months, which is just, I had never heard of that before a couple of years ago. Interestingly, one of the main upcoming conservation concerns is actually the presence of orca whales in Hudson Bay and in other northern regions. So historically, we don't know of any instance where killer whales or orcas have ever been found as far north as they have been in the past few years. There are no local names for orcas in native languages because they've never been there. But as we have had longer and longer ice-free seasons, we have seen orcas making their way not just into Hudson Bay, but into estuaries in more northern regions as well, preying on beluga whales as well as narwhals. Now, oops, where are we here? Here we go. The other concern that we have for beluga whales coming up in the next little while is the presence of an extreme amount of shipping in their range. So as we start to see less and less sea ice, especially in summer months, right now, there are not a lot of large ships that can use the area where belugas are mostly making their homes because it's too iced up. But projections from WWF have given us, once we're starting to look at the year 2040 and belong, that any ship, whether or not it's an icebreaker, will be able to use these areas as well. So most of the stress on these animals and on their populations does come from the fact that they are species of the ice. And as we see the ice disappear, they're going to get pushed into smaller and smaller areas. All that being said, do keep in mind that they're really healthy populations worldwide. There are some of the populations, like I said, there are 29 worldwide. Some of them are not doing super awesome, but they are the exception rather than the rule. So populations like the Ungava Bay population and the St. Lawrence estuary population are very small and facing certain stresses, but overall, globally, those 29 populations and the 150,000 animals, they are considered to be of least concern globally. So they are very well set up. They have relatively few complications, relatively few concerns. It's really just going to come down to that fact that humans and orcas and other organisms are all going to be sharing those same areas. So just as an example, this is in the St. Lawrence estuary. You can see a beluga whale right beside a large shipping vessel. Now, just to wrap up, because I know that a lot of people here care a lot about whales and care about what you can do for whales, I'll just put a plug in for things that you can do, because I know that for me, I always like to know what my action items are. There are a number of citizen science projects involving beluga whales, but I think the most fun one is actually based out of Churchill. So in Churchill, like I say, 3,500 whales all through the summer months, and every time the tide is high, an organization called Explorer.org sends out a boat with both an above water camera and a below water camera. And it will live stream pictures of beluga whales. And this is for fun. I mean, you can also go onto Explorer.org and look at pictures of kittens for hours upon time. Or you could look up beluga whales. And if you choose to look at beluga whales for hours and hours upon a time, you can actually use that time to help generate more knowledge and more data for projects that are tracking the health and well-being of beluga whales in the Churchill River estuary. So this is done through a project called Beluga Bits through the Zooniverse Foundation. And you can just go on, you can take screenshots. It'll give you instructions on how you can progress and learn how to sex whales, learn to count their teeth, learn to look for identifying scars, so that they are learning things like the social structure of these whales, the life history of these whales. So how often is any one female having a calf? How long are those calves staying with the mums? How are they using their habitats? because, like I say, most of what we know about beluga whales has actually come from aquariums. And that's cool and great, but it would be even better if we could know what whales do when they're in their natural habitat, and how can we best support whales and keep them safe and happy in those habitats where humans and other animals use the area too. So getting this kind of on the ground research where beluga whales are in the water doing their thing can just be incredibly beneficial for future conservation initiatives with these animals. So if you're at all more interested in that, this would be an example of a picture that you could see in this camera, and you would say, I see a whale, I can maybe identify its gender, I can maybe identify how old it is based on the training that you get, and that can be information that then goes into that important research. Plus you get to look at whale pictures, so nothing too wrong with that. So all of that training is provided, and if all you want to do is look at whales, that's awesome as well. If you want to use that time to contribute to science, that's great too. So with that, I will hand things over to Kendall for questions.
Great, thank you so much, Eleanor. That was wonderful. Before we start the Q&A, I just want to remind everyone who's watching, if you have a question today, you can submit that in your control panel under the questions field. Okay, lots of great questions here. We'll get to as many as we can by the top of the hour. First one is, if the ice is melting or changing in the Arctic, does that mean that food supplies and algae are also disappearing?
Oh, fantastic question, because short answer is yes. Long answer is that this is something that is very much being studied right now, because we know that the algae that lives on the sea ice is not the same kind of algae that we have that lives in open water. And as we start to see ice disappearing and we lose that algae and we lose the organisms that feed directly on that algae, this is thought to be one of the reasons why we're seeing things like orcas moving in and different fish species moving in. And we just don't know right now whether or not beluga whales would be able to modify what their prey species are to account for these changes or not. It's just happening so quickly, and there's still so much being learned.
All right, and just really quickly, someone's requesting that you put that last slide up that shows the difference between males and females, and we'll leave that up for just a little bit, and we'll put that contact information back up. All right, next question. The feeding by sucking in, etc., seems relatively non-discriminatory. Do the whales suck in harmful items ever?
You know, because we are looking mostly at whales in the Arctic, where my mind went, and maybe where your mind goes as well, is things like sucking in plastic or fishing nets and things like that. We don't see, upon examination, the same kind of level of plastic pollution in the stomachs of beluga whales as you might in more southern whales, simply because of the fact that there's a lower plastics load in the Arctic relative to what you can have at lower latitudes. That being said, the narwhal, it actually uses its primary method of feeding is just by sucking. They feed lower down, they feed off the seafloor bottom, and they also don't seem to be full of plastic either. So whether they are able to discriminate more, whether there is simply less plastic or it's a combination of the two, they seem to do okay with it.
All right. And do we know why young whales turn gray? What's the reason for that?
In terms of the evolutionary reason for it, there are lots of guesses. You know, as time goes, they simply lose their melanin, and they're born dark and they get light as they age. And thoughts might be around that the younger organism, like the younger whales who are possibly more susceptible to predation, can be harder to see if they're darker in the water, whereas the older whales who are more able to move around and defend themselves and they're just bigger and harder to take, it doesn't matter as much if they are light colored, and then they're also less susceptible to predation by by polar bears possibly. There are lots of guesses and no one answer on that one.
All right. And since the pods tend not to interbreed, are there any issues with genetic defects?
Yeah, so it's not that the pods don't interbreed, it's that the populations don't interbreed. So the Western Hudson Bay population, like I said, is around 60,000 individuals. And you get two kinds of pods. You get the bachelor pods and you get the family pods. And the bachelor pods obviously have to make contact with the family pods for the breeding to happen. What there's less between is like the Western Hudson Bay and the Eastern Hudson Bay population seem to breed within themselves more than within other groups. Now, populations that have been cut off, like the St. Lawrence estuary population, we definitely see a lot of lower genetic variability in that population. And it's thought that because of that lower variability, that population has become more susceptible to things like birth defects, or also possibly more susceptible to the effects of pollution because they don't have the genetic variation to maybe move past that.
Mm-hmm. All right, well, we're getting close to the top of the hour, so the last question I'll end on, someone was wondering about if we know of any trips to see the belugas. Can you tell us about that?
Ooh, I would be happy to, because that's, not that I don't love all the trips, but I think beluga whales are always my favorites. So Natural Habitat Adventures does offer beluga whale specific trips in the summer, and these are based out of Churchill, Manitoba, and run in July and early August for the most part. So we go out, so we meet in Winnipeg, we fly out to Churchill. We have generally about 6 full days in Churchill, and we spend as much time as possible on the water with the whales. And we might do whale viewing from Zodiac boats or from a larger whale watching jet boat. And we also have opportunities for doing things like kayaking or stand-up paddleboarding with the whales as well, which if you're comfortable doing that is, I think, one of the most mind-blowing ways to see them. And my favorite part about that itinerary is how many different how many different ways we get to go out there and interact with the whales. So big boats, small boats, and everything in between.
Yeah, I was telling you, Eleanor, before the webinar started, there was a video I saw of one of my coworkers kayaking with the whales around her, and it was just the most incredible video. It looks like such a fun time. Yeah, thank you for putting that contact information up. So if anyone is interested in learning more about that trip, give us a call at the number you see on the screen, or you can send us an email, and our adventure specialists are always around and happy to answer any questions you have. All right, Eleanor, back over to you for our closing comments.
Thanks, Kendall, and I won't go on too long. Just thanks everybody for coming on today. Thanks for letting me talk about whales. And if you would like to come back next week on Monday, I will be talking about wildflowers. A little bit of a change, but just as fun.
Yeah, all right. I look forward to that. Thank you so much. And my thanks as well to everyone who tuned in today. Join us tomorrow for our next Daily Dose of Nature. You can check out this week's lineup, including registration links, on our website at nathab.com/webinars. We did record today's presentation, and we'll have the replay available on our website soon. And with that, I will conclude the webinar. Goodbye, everybody.